Have you ever just stopped and wondered how pretty much all of the world's information can fit right in the palm of your hand? Well, it's not magic, it's silicon. And today we're going to peel back the layers on the invisible engine that powers, well, everything in our modern world.
So, our journey starts with a really simple but honestly profound idea, what we call the relentless shrink. It's the secret sauce, the magic ingredient that makes all your devices faster, smaller, and way more powerful year after year.
I mean, really think about this for a second. The computer that guided the Apollo 11 mission, it was the size of a suitcase. Your smartphone is literally thousands of times more powerful, and it just slides into your pocket. So how is that even possible? The answer comes down to one single crucial idea. It's all about transistor density growth. So what are transistors? They're just tiny little electronic switches, billions and billions of them, that are the basic building blocks for all modern electronics. And our ability to cram more and more of them into a teeny tiny space is the single biggest driver of technological progress for the last 50 years. Period. But here's the thing, this incredible progress, it wasn't just random chance. For half a century, it followed this surprisingly predictable beat, an observation that pretty much became a law for the entire tech industry.
Yeah, way back in 1965, a guy named Gordon Moore made this simple observation. And what's so fascinating is that this wasn't some fundamental law of physics, it was a prediction. But it became a self-fulfilling prophecy. Why? Because it set a target, a pace car, for the entire semiconductor industry. It was like an industry-wide roadmap, and the economic pressure was just immense. If your company couldn't keep up, you were toast. So this prediction kicked off an intense, relentless race. And the results are, well, they're staggering. Back in the 70s, a chip had, a few thousand transistors. Fast forward to the 2000s, and that number jumped to hundreds of millions. And today, we're talking tens of billions of transistors on a single chip the size of your fingernail. The scale is almost impossible to wrap your head around.
300 million. Just let that sink in for a second. That's how many transistors engineers can now cram onto a single square millimeter of silicon. A millimeter. That's about the thickness of a credit card. It is a truly mind-boggling feat of engineering.
And you knew there was a but coming, right? Here's the twist. That beautiful, predictable, exponential curve is slamming into a wall. The easy days of just shrinking everything down, well, they're over.
So here's the central conflict we're facing. For decades, the promise of Moore's law was simple. Technology would just keep getting better, smaller, faster, cheaper. But now, the problem is that the fundamental laws of physics and the harsh realities of economics are starting to push back. Hard. Okay, let's break down these challenges. First up, we are hitting hard physical limits. At this tiny, tiny scale, you run into some really weird quantum effects. Electrons literally start tunneling through barriers they shouldn't be able to cross, causing leaks. Next, all these billions of switches packed so tightly together generate an insane amount of heat. And finally, the economic cost. Oh boy. To build a new factory, a fab, for these chips now costs tens of billions of dollars. The complexity of the whole operation is just off the charts. But look, this isn't a story of doom and gloom. Not at all. This is where human ingenuity really starts to shine. Because when you can't just build smaller anymore, you have to start building smarter. Let's see how engineers are doing exactly that.
The first brilliant solution is to go 3D. It's like real estate, right? If you run out of land in a city, you don't keep building wider, you build skyscrapers. That is exactly what's happening on chips. Engineers created vertical structures called FinFETs, which add a 3D fin for way better control. The next evolution is even cooler. It's called Gate-All-Around, or GAA, and it completely wraps the transistor's channel. It's like going from a simple on-off switch to a super precise dimmer dial. This lets us stack whole layers of chips on top of each other, massively increasing density.
The second solution is just as clever. Chiplets. See, instead of trying to make one giant, perfect, do-it-all chip, which is incredibly difficult and expensive, companies now create smaller, specialized chiplets. You can just think of it like Legos. You can build a much more powerful and efficient system by combining different specialized bricks instead of trying to carve the whole thing out of one giant, flawless block of marble. So this is the new toolbox, the arsenal for tomorrow's engineers. You've got these incredible 3D architectures for vertical power, you've got the Lego-like chiplet approach for custom efficiency, and we're even exploring revolutionary new materials beyond silicon, like graphene and carbon nanotubes. All of this is designed to keep the engine of progress running for decades to come. Okay, I know this all sounds super technical, but why should you actually care about any of it? Because this invisible engine, this constant innovation, is directly shaping your future. Honestly, every single major tech trend you can think of is powered by this. The AI revolution, it requires an absolutely massive amount of computing power from these dense chips. Your smartwatch, your phone, your earbuds, they only exist because of this relentless push for miniaturization. Even critical gains in energy efficiency rely on packing more performance into every single watt of power. This stuff is the foundation for, well, everything. So, we'll leave you with this thought. For half a century, the goal was simple: shrink, just make it smaller. But now the mandate has totally changed. The goal is to build smarter, build up, build out, and build with totally new kinds of building blocks. So if the age of shrinking gave us the internet and the smartphone, what impossible things will the age of building smarter unlock for us next?